to be talking about solving polynomial equations, and this is day 1 of chapter 5, section 5. First off, we can solve this polynomial equation by factoring. So what we can do is we can factor out the common monomial, which is a, and we get a squared minus 4a plus 4 equals 0. And now we can also factor that to be a minus 2 squared. We can set each factor equal to 0. So a equals 0 and a minus 2 squared is equal to 0. And we can square root both sides. And we get a minus 2 equals 0. So a will equal 2. So those are our two answers for a. The next one is we have v cubed minus 2v squared minus 16v equals a negative 32. So what we need to do is have this all equal to 0. So we're going to move the 32 over, the negative 32 over. So we have v cubed minus 2v squared minus 16v plus 32. And whenever we have 4 terms, we can use grouping. So we can write this as v squared times v minus 2 negative, and then, minus 16 v minus 2. Set these, we have to rewrite it as v squared minus 16 times v minus 2, and we can still continue to factor the v squared minus 16 to v plus 4, v minus 4, v minus 2, or you could have just set v squared minus 16 equal to 0 and solved it that way. But our answer is going to be plus or minus 4 and 2. Let's do 2 more of those. We have 9m to the 5th equals 27m cubed. So we can subtract. So we have 9m to the 5th minus 27m cubed equals 0. I can factor out a 9m cubed and get 9m cubed times m squared minus 3. We set both equal to 0. 9m cubed equals 0, m squared minus 3 equals 0, and we're going to end up with 0 and plus or minus the square root of 3. Next up, we're going to subtract that 14p squared equals 0. We can factor this as p squared minus 4. And p squared minus 10 equals 0. We set both of them equal to 0, and we end up having plus or minus 2 and plus or minus square root of 10. So we can use factoring and square roots to solve for these. We also can use it by sketching a graph. Okay, so the first thing we're going to do is we're going to find the zeros of the function, then we're going to sketch a graph of the function. So we can find the zeros algebraically by factoring. And if we were to factor this, this is going to be x squared minus 9 squared. And so our zeros for this are going to be plus or minus 3. So we can graph that on here, plus or minus 3. Our constant, positive 81, is going to be our y-intercept. We're going to go by tens for the y's. So it's about there. And now what we need next is the end behavior. So we're going back to the end behavior. And the degree for this one is even. And the leading coefficient is positive. So if that's the case, our end behavior is going to be going up on both sides. So we are going to follow those curves to those points. And now we have a rough sketch of our graph. So let's try another one of those. So what we can do first is factor out a negative 2x cubed, and we have x squared minus x minus 20. A negative 2x cubed gives us x minus 5 and x plus 4. Set all of those equal to 0, and our intercepts are going to be 0, 5, and negative 4. Our end behavior is going to be our degree, which is odd, and our leading coefficient, which is negative. And that is going to be up and then down like that. So we're going to go 0, 5, and negative 4. And we're going to start upwards, and we're going to curve around a little bit, and then back up, and then down. So that's our rough sketch using our x and y intercepts and our end behavior. Now there's another method of being able to find your solutions of the equation, and that's usually using the rational root theorem and synthetic division. And the rational root theorem says, if you take the factors of the constant over the factors of the leading coefficient, that will give you a list of possible zeros, and we call that P over Q. We put P over Q. So let's put P over Q to get our possible list of zeros. And our factors of the constant, so factors of 6 is going to be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Factors of our leading coefficient is 1, so it's plus or minus 1. So if we simplify that, our possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So we can use any of these to try and see if they are solutions. They are possible solutions. And to figure out if they're possible solutions, we can try one using synthetic division. So I'm going to try negative 1 first. And let's see if that works. So we're going to put this into synthetic division. So I'm going to do 1, negative 2, negative 5, 6. Bring down the 1, negative 1, negative 3. 3, negative 2, 2. Now our remainder is 8. If we do not get a remainder of 0, this does not work. It is not a solution. So I'm going to move on to 1. I'm going to see if 1 is a solution. So let's do 1, negative 2, negative 5, 6. And our remainder is 0. So that means 1 is a solution. And what we can do now is that we can write this as a trinomial, x squared minus x minus 6. And we now can very easily factor this as x minus 3 and x plus 2. And we now can say that our zeros, or our solutions, are 1, 3, and negative 2, using our rational root theorem and synthetic division. Let's try one more of these. This one we have a leading coefficient of 3, so we're going to have a lot more possible solutions. So let's do P over Q. The factors of 24 are plus or minus 1, 2, 3, 4, 6, 8, 12, and 24. And we're going to put all over the factors of the leading coefficient, which is 1, and 3, plus or minus 1 and 3. So what we're going to do is we're going to rewrite this into one list of possible solutions. So we have to put everything over 1 and then everything over 3. We don't have to add repeats. So our list is going to be 1, 2, 3, 4, 6, 8, 12, 24, plus or minus 1/3, 2/3, 4/3, and plus or minus 8/3. So this is our possible list, and this is quite a large list. So it could take us some time to find which zeros are solutions. So what we can do is we can get out our graphing calculator to give us a guide of where to start in finding our solutions. So what I'm going to do is I'm going to go to my y equals, and I'm going to put in this polynomial. So 3x cubed plus x squared minus 38 x plus 24. So we're going to plug this in and we're going to graph it, and just very quickly we're going to roughly see if there's any whole number solutions. So I already see a -4 and a 3. So we can try a -4 and a +3. That's kind of a good starting point for us. So we can use a -4 and a +3. Okay, and so we're going to use, let's do -4 first. Actually, let's try 3 first. Using our synthetic division. So we have 3, 1, -38, and 24. So I'm going to bring down the 3. I get 9. I get 10, 30, -8, and -24. So this one works out. So I know that 3 is a solution. Now, what we can do is we can try -4 using synthetic division again and see if that works. So we bring down the 3, -12, -2, 8, and then 0. So we know now that -4 is definitely a solution, and we can write this as 3x minus 2, and if we set it equal to 0, it gives us our third solution. So we have 3, -4, and 2/3. So if we have a lot of possible solutions, you can use your graphing calculator as a guide of where to start to pick to put into your synthetic division.